So how can you do this problem in 60 seconds or less? The only reason it's 60 is because this passage takes forever to read. For an electric field passing through a flat surface perpendicular to it, an electric flux of the electric field through the surface is the product of an electric field's strength and the area of the surface. A certain flat surface consists of two adjacent squares, where the side length in meters of the largest square is 3 times the side length in meters of the smaller square. That's important. So let's draw this out. So this is a larger square and this is a smaller square. An electric field strength of 29 volts per meter, blah, blah, blah. If the total electric flux of the electric field through this surface is 4640 volts, what is the electric flux in volts meters of electric through the larger square? So what we do is 4640 over 10 multiplied by 9, cancel this out, and you have 3600, 540, and 36, which is 6714, and the answer is 4176. How was I able to do this problem so fast? Again, this is lots of fluff in this passage, so let's try to identify what's really important. The electric flux of the electric field through the surface is the product, that's important, of the electric field's strength and the area. So check this out. So if you could call this, I don't know, the electric flux, EF, for example. So EF is equal to electric field strength, so strength multiplied by area. Here's the thing, we are going to find out later that the strength is a constant at 29. So the strength is always 29, so therefore it's not important. This whole thing is not important. So we only have to worry about the area. Now, what can we say about the area? A certain flat surface consists of two adjacent squares, where the side length in meters of the largest square is 3 times the side length in meters of the smaller square. So if we have two adjacent squares, and this is 3x and 3x, and the smaller square is x and x, the area here is 9x squared. The area here is just x squared. Now, if the total electric flux of the electric field through the surface is 4640 volts times meters, what is the electric flux in volts times meters of the electric field through the largest square? So what we know is this whole thingy through both of these guys is 4640. Now the question is, how much of it goes through this one square, which is the larger one? The total area is 10x squared. The area of the largest square is 9x squared. So all you have to do is multiply 4640 by 9 over 10, which is equivalent of 4640 divided by 10 multiplied by 9. Cancel the 0. You have 464 times 9. Calculator to the rescue if you want. I don't like to use calculators, so I do 400 times 9, 60 times 9, and 4 times 9. So I get 3600, I get 540, and I get 36. Add this up. 6, this is 4 and 3, 7, this is 1 and 4. So I get 4176. That is the answer. That's it.